Questions 11 and 12, both are quite tricky actually, especially question 11. So what have you got? What's the major product of the reaction between 2-methyl-butene and iodine monochloride? So 2-methyl-butene. So before this has reacted, it's had a double bond between carbon numbers 2 and carbon number 3. So this is carbon number 2, 2-methyl, there's the methyl group. Butene, so it's had a double bond here. So the I and the Cl have bonded across the double bond. Now they're in the wrong position. They need to bond across this double bond at carbon number 2. They're in the wrong position. C are in the right position and D are in the right position across in between carbons number 2 and number 3 where the double bond has been. So ICl has bonded across that double bond. So A and B are automatically incorrect. The question is, which way round are these two? Well, if you imagine, if you had HBr, let's say, H is HBr, the Br is slightly electronegative, so it gets a delta minus, and the H has got a delta plus, and the H bonds on first because it's got the delta plus. So the double bond would attack the H plus of HBr, and the H bonds on to the carbon that's got the most hydrogens. So the H would bond on here, and then the Br would bond on there. So now, instead of HBr, you've got ICl. So which way round is the delta plus and delta minus on ICl? Well, Cl is more electronegative than I because it's a smaller atom and withdraws electrons closer into its nucleus more readily, so more strongly. So it will be delta plus on the I and delta minus on the Cl. Let's just show you that. So it's delta plus on the I and delta minus on the Cl, just like I had HBr with Br being more electronegative than the H and ended up with a delta minus on the Br and a delta plus on the H. That's the way this goes because Cl is a smaller atom than I and would end up with the delta minus across this polar bond. So in other words, ICl is similar to HBr, and if the I were an H of HBr, you know that it would attack, join on across the double bond onto the C of the H there, because that C has got an H, this C has got no H's, and the H of HBr would bond onto the carbon that's already got the most H's. So the I is similar to the H and would bond onto there, and then the Cl would bond onto this one. So the answer is C and not the other way around. If you want to know the understanding of why a H of a Br or an I of a Cl would bond onto the carbon with the most number of H's, it's because when it bonds on, that C doesn't have the Cl bonded to it yet. It would have a plus, and that would be a tertiary carbocation, a C with a plus with 3 other carbons around it making it stable because the methyl groups repel electrons. So that is why it happens. But it's not asking why it happens, you just need to imagine that ICl is similar to HBr, and then you can work it out knowing that the H, or in this case the I, bonds to the carbon which has the most hydrogens, and that is the position of the double bond at carbon number 2. So that is why these two are incorrect. They're bonding across between carbons number 1 and number 2 and not between 2 and 3. Which statement is not correct about the industrial preparation of ethanol by the hydration of ethene? So the reaction is catalyzed by an acid. Not sure. So we'll leave that one for now. A low equilibrium yield of ethanol is acceptable because unreacted ethene is recycled. Not really sure. A and D could be plausible, but if we're not sure, let's have a look at B and C. Let's work out the others. The higher the pressure, the higher the equilibrium yield of ethanol. Well, I've got 2 moles of gas on the left, 1 mole of this and 1 mole of this, and I've only got 1 mole on the right, so I've got 2 moles of gas on the left and 1 on the right. So a higher pressure, by Le Chatelier's principle, if I increase the pressure, it will try and lower the pressure. It will lower the pressure by reducing the volume and making 2 moles of gas into 1. So yes, increasing the pressure would increase the amount of ethanol by shifting the position of equilibrium to the right. So that is definitely right. A and D we're not sure of. Let's check out D. If that's the one that's not correct, we know we've found it. The higher the temperature, the higher equilibrium yield of ethanol. So in other words, does increasing the temperature make more ethanol? Does it shift it to the right hand side? That's what the question's asking. Well, it's got a minus here, so it's exothermic. So that means that when this reaction happens, it gives out heat. If I increase the temperature, higher the temperature, by Le Chatelier's principle, this reaction will respond to try and lower the temperature of the system, lower the temperature of the surroundings, and oppose the change. That's what Le Chatelier's principle says. So if I increase the temperature, it will try to lower the temperature of the surroundings. Well, it's not going to go to the right and make more heat. It would shift to the left to reduce the amount of heat. So that increase in the temperature wouldn't increase the equilibrium yield of ethanol. It would actually increase the equilibrium yield of ethene and water or steam by shifting the equilibrium to the left, reducing the amount of heat in this direction, which is endothermic.